In graph theory, we say that the diameter of a graph is the maximum distance between any pair of vertices in the graph, where distance is defined as the length of the shortest path between the vertices. So I have this graph down here. Let's take a look at how to find the diameter of the graph. So it has a total of 7 vertices, which I've labeled from A through G. To find the diameter of the graph, we're just looking for the maximum distance between any pair of vertices in the graph. So the way that we can find the diameter is we just need to find the distance between every pair of vertices. Now, one thing to note about this graph is that it is not a complete graph. In other words, every vertex is not directly connected to every other vertex by an edge. So for example, A is not directly connected to B, C is not directly connected to F, E is not directly connected to G, and so on. So because this is not a connected graph, it means that there must exist non-adjacent vertices. So in other words, there must be some vertices in this graph that have a distance of at least 2. So you must travel across at least 2 edges to get to them. So because of that, we don't need to worry about the vertices that have a distance of 1. So for example, to go from A to D, that's a distance of 1. We only have to cross one edge. We don't need to consider that distance because we know that the diameter of the graph, or the maximum distance, must be at least 2. So if we start with vertex A right here, let's find the distance between vertex A and every other non-adjacent vertex in the graph. So for example, the distance between A and vertex B is 1, 2. We have to cross 2 edges to go from A to B. And that's the distance because it is the shortest length from A to B. So for example, if we instead considered this path that we could take right here to get to B, well, we had to cross 3 edges, but the distance is the shortest path between the vertices. So the distance has to be 2 in this case, because that's the shortest way to get from A to B. So let's go ahead and write the distance between A and B is 2. So let's denote that as D for distance. Distance between A and B is 2. Then if we consider the distance between vertex A and vertex E, that would also be 2. So we have to cross 2 edges to go from A to E. So let's write that down. Then if we consider the distance between vertex A and vertex F, that would also be 2. And lastly, if we consider the distance between vertex A and vertex G, that turns out to be 1, 2, 3. That's the shortest path to go from A to G. We have to cross 3 edges. So let's write that down. So those are the distances between vertex A and every other non-adjacent vertex in the graph. So I'm going to go ahead and write down the distances for all the remaining vertices. All right, so when we calculate the distances between every pair of vertices in the graph, we'll find that the largest distance that appears 3 different times is a distance of 3. So we would say that the diameter of this graph, let's call it graph G, is 3. So that will be our final answer for this one. So that was just a quick example of how to find the diameter of a graph.